ELISA is short for enzyme-linked immunosorbent assay. With this plate-based technique, we can detect and quantify soluble substances such as proteins. During an ELISA, the antigen, which is the target molecule, is immobilized and specifically detected by antibodies, which are enzyme-coupled. When providing a colorless substrate, the enzyme produces a measurable, colorful product. An antibody is attached to the bottom of the well. This antibody is specifically designed for binding a specific protein of interest. Another soluble antibody is provided. The antibody is also specifically covering protein X. This antibody is conjugated to an enzyme. When we now add a substrate, the enzyme can convert it to a colorful product, which can be measured later. There are many variants of an ELISA. In the direct ELISA, the antigen is immobilized on the bottom of the plate, and the enzyme-linked antibody directly binds to the antigen. In the indirect ELISA, a primary antibody binds our antigen, and then a secondary antibody binds the primary antibody. The secondary antibody is enzyme-linked. The most common type is the sandwich ELISA. A primary antibody is immobilized and captures the antigen of a solution, and another primary antibody specifically binds the same antigen. But all three ELISAs have one thing in common. The last antibody binding is always conjugated to the enzyme which confirms binding. Here we provide an example of an ELISA. For this sandwich ELISA we have two wells, both coated with primary antibody specific for protein X. On the left we provide a sample containing our protein. On the right we have the control without the target protein. Our antigen in orange will be immobilized. A washing step will discard everything else. Now we provide the enzyme-linked antibody. It will bind our antigen in the left well and remains bound after washing, whereas the antibody is discarded in the control. In the last step, a colorless substrate is given. Since the enzyme, in most cases horseradish peroxidase, is exclusively present in the left well, it produces a measurable, colorful product here. This can be investigated and also quantified using spectrophotometry. The control remains colorless since substrate is not converted here. If you want to have a closer look into the direct or the indirect ELISA, you may click one of these videos here.